explanation. If you are explaining something and you repeat that word, kind of like would I say redundant, like what does it mean to project something? No, in that word projection, there's project there. Yes, you know that we're projecting. So that's in the definition, you should not really say the word verbatim like that. I don't know if you get what I mean.
Release though. Sir.
Okay, just try, just try, just try. Don't worry, try, try. However way you want to do it, just try. Try now, or did I see your morale?
So is it me?
Yes.
Oh, it's something that is being. Oh God.
I understand anyway, but I feel like you know what you want to say, but you don't know how to say what you want to say,
Mm,
right?
yes, sir. Yes, sir.
From what you are saying, I feel like you know what you want to say, but you don't even know how to put the words you want to put it in. So who can try? Somebody else, in your own words, what is protector? Shakiruddin, can you help us?
When something is thrown upward,
Okay, thrown upward. Okay, that's a good one. Something is thrown upward. Somebody else is something different. You have a contrary. Uh, yes, somebody else, please. One thing you must learn to or try to do that helps learning is this, that you don't just cram verbatim. I know that yes, there are some terms that are technical terms, and that's why all throughout the course you try to make it practical. So like Sakiruddin said, he says an object that is being thrown upward. That's a good example of a projectile. That means you really understood regularly. That means you really understood that concept of a projectile. How about if somebody joined us? How about Vera? Yeah, Vera. So Vera, please, I want everybody to be involved. Though. While I'm working, I just want us to be involved. At least let's do a recap. It's not just about accumulating knowledge. Let's see how well we've gone. Okay. And that's what we also need to go back to the notes on our own. So somebody else, I was calling on Vera. Vera, are you here? I know you are here, but are you really here? Vera, hello? Vera, are you there? Okay. Anyway, well, basically, you can define a projectile as an object that is launched, whether it's upward or downward. Sometimes the projectile does not launch upward. It's not only thrown upward. So most of the time it's thrown upward, but sometimes it can be launched downward. Let me give an example. Like when a rocket fires, sorry, when a jet fighter fires a rocket, no, that's not the project that's being launched upward. It's being launched downward. Okay, because I even remember during our revision to students, a similar question was asked to which of the following is a projectile. So a palm nut even falling from a tree is an example of a projectile. Just that simple motion. So when an object is launched, whether upward or downward, and it moves under the effect of gravity, then that object is required. Is defined as a projectile. So in the case of a stone being thrown upward, like basketball, you launch it in space, try to, score
Sir,
a point.
sir.
Yes, yes.
Like, can I say that it's something that is in, like, is the highest point of his life, or
Well, who is speaking?
is
Okay,
Ella?
please, yes, go on. Ella,
Like,
okay, your name is
can I
Ella,
define
yes.
that like something that like is in the highest point of his life?
Not really. Though during its flight, it attains a highest point, which is called the maximum height. But
Mm,
you can say that a projectile is something that is currently on flight. When we talk about flight now, we're talking about being in air. So currently it's on the flight and that is being propelled by gravity. So anything that is in air and is being propelled by gravity is a projectile. So if I throw my cup up, that cup on its own has no other force to propel itself. So it is a projectile. Fire a catapult at its age, when you release it from a slingshot, it is moving in the air, it will attain a particular point and curve and then hit the target or miss the target. So it's also a projectile. So the idea is also good that the object is in flight because for it to be considered a projectile means that it is in the air, right? And in the air, it will reach a maximum height before coming or curving downward. So we see a relevant example. So that's a good one. So who can define the time of flight? Since you've mentioned time of flight, what can you define time of flight as? Yes? Anybody?
sir, please, what do you say again? Recall the cap.
What is the what?
Like, what was your question?
I said who can define what time of flight is?
I'm like,
But you did all this things and okay, just anybody. Okay, let's is somebody saying something. We don't have an idea.
sir,
Yes.
I don't know, but let's say I would say like it is the particular like time at
Yes.
which the flight gets to its
Like I
maximum
really
point.
go okay. I really get what you're saying. Like you are getting it, but you're not
Okay, sir. So I said that it is the time of flight. No, it is the time at which the flight gets to its maximum point.
okay, that yes, you can define that as the time of flight. When I throw a ball upward, if you pick a particular time for which you keep ascending or being in flight till it gets to that maximum point and then it will now fall back. So that time can now be called the time of flight. And the time for it to go up and come down is called the total time of flight. All right. So do we recall the formulas for finding these parameters that I said?
So I
Yes,
did a
class.
question.
Yes, I said the formulas for finding this parameter. Like let's say time of flight. All the formulas for finding time of flight.
So should I say U square? Yes, U square sin theta over G. No, the section is from one other one.
Okay. Yes, exactly. I'm saying for maximum height. This is u squared times square theta over 2g. But the formula for time of flight is actually 2u times theta over g. Now, so we'll be able to have our proper class. All right. So, anyway,
So
you
do
are
you
trying,
sin theta over G?
but just for yes, 2u times theta. Yes. I try to pick our time and revise the notes that you were given. You were you were there during the class and protesters, right? So is there anybody here that was not there during the class on protesters? So there's nobody. Okay. So I think I was muted.
Hello, Emmanuel, you're welcome. Mr. Chika, are you still there? Vera. Hello, Vera. Hello.
Hello.
Hi.
Oh, good evening, ma'am. Good evening. So, okay, Mr. Chike, we have a new student here, so I just wanted to welcome him. So you can continue. Emmanuel, you're welcome. Hello, Emmanuel, can you hear me?
Yeah, can anybody hear me? Hello, can anybody hear me?
All
So
right.
please,
All right. So, Emmanuel, sorry, I want to educate our new students. Emmanuel, hi, can you hear me? All right, so when you want to talk, there's a microphone icon. Okay, yes. Okay, you should click on the microphone icon when you want to talk, okay, so that people can hear you. So whenever you want to ask questions, click there. That's the only time people here can hear you. All right, so welcome, Mr. Chika, you can continue.
okay, but everybody, can we all hear me? Because
Yes, I can hear you.
Me, I'm struggling to hear you, sir. I'm not hearing you clearly. I'm struggling to hear you.
wait, is that the same with everybody?
Yes, sir.
Wait, you're all struggling to hear me. Like I'm not loud enough.
Yes.
But how about now? Is it better?
Yes.
Okay, all right. So like I said we're going to do a revision on your the topic we've done before, and then we'll now move forward. So you said you are on linear momentum according to everybody here was in the last class, right? So according to Sam Sirudin,
No,
right? Okay.
No,
impulse
sir.
and momentum. Impulse.
Yes. Impulse and momentum, yes. Sirudin. Okay. Wait, is that your name? Is that actually your name?
Yes.
Okay, because I need to be sure because some people use maybe an account of maybe their dad or mom. So all right. So you say you stopped at impulse and momentum. So I said that that's under Newton's third law of motion. So that means you people must have dealt with Newton's laws of motion. Well, you said no. So that means wait, I'm coming. Let me just confirm from the list of this topic. So at the end of the class, I will make sure to provide a note so that you can be able to follow through. Okay. All right. All right. So I believe that we must have gone through measurements and units, right? First topic, measurements and units. Hello? Please, I need us to be talking so that we can know how far we are going to cover. Please. Have we covered measurements and units?
No, sir.
Vera,
No,
No, sir.
Vera,
no,
I think you were in the first class, right? You joined us in October.
yes, yes, ma'am.
So I think people have covered this topic, measurements and units.
No, we
No, no,
haven't.
no.
No.
Okay. Okay.
Hmm.
Okay. So where do I start from? Do I start from that point? Okay, because okay, well, so just give me a moment, okay? Shortly I'll be back. Just give me a moment.
All right, so everyone, welcome back. I hope we're still here with me.
Yes, sir.
All right. So in order not to cause any breakage to the flow that you have, so we're just going to take a standalone topic that you can be easily understood. That can be easily understood. So let's look at the topic of friction. Okay, we'll look at the topic of friction, and then from there we'll now be able to do some calculations on that friction. Okay, so friction is opposition to motion. Okay, I'm coming so that I can be able to use the slide. Okay. All right, so I hope all of us are still together.
Yes, yes.
Yes, sir.
All right. So that's use the other. I'll be right back. Okay. Okay. I have it now. So I can be able to see what I'm saying. I want to use this slide because it's loading. Okay, I have it now. So I'll be sharing my screen so that you'll be seeing what I'm doing on my screen. Okay. So everything will be very, very clear. All right. So here we are. Okay, my screen is not even shared. So we're looking at the topic, okay, so that it doesn't disrupt the flow that you've had. We're looking at friction, and then at the end we'll be sharing past questions on it. Now, first of all, when we talk about friction, we have to talk about motion, first of all, okay, which is one of the topics you would cover later on. So, in friction, I hope you can see my screen, everybody.
Yes.
Okay. So now in friction, first of all, when we talk about friction, we have to talk about motion. Okay, please. In this topic, we're going to be able to touch about 2 or 3 other topics in your syllabus because it revolves around 2 other topics. Motion and then force, because friction is a force. Now, for us to understand friction, we need to first of all understand motion. Now, what is motion? Motion is the change in position of an object with respect to time, right? So like initially, I can be at this point and then I move on to another point. That means I have moved in layman terms or I have exercised motion. And there are various or several types of motion. Number one, you have linear motion, which is the motion of an object in a straight line. I hope my voice is very, very audible.
Yes, sir.
All right. So we have number one, we have linear motion, which is the motion of an object in a straight line. We have oscillatory motion, which is a vibratory motion. For example, you have your simple pendulum. You have your simple pendulum whereby It is hinged at a particular center point, which is called the equilibrium point, and then the pendulum swings by and by. You understand me? That's an example of a vibratory motion. That means it is the particles are vibrating about a particular point. So we have linear motion, which is the motion of an object on a straight line. For example, you can have a car moving on a straight road. That's an example of linear motion. Not the tires, because the tires are exhibiting rotational motion, but the car itself is moving in a linear direction. That's why you have equations of linear motion, which is another topic we will also cover. Now, having looked at motion, that means motion is very essential for us as beings because we need to move around. Like in biology, you learn reasons why organisms move around. You learn about phototropism, I think, which is an object moving around in search of light. For example, plants, right? You can see different trees, the same trees rather, can grow at different rates, even under the same condition because of their response or motion to different things. So, for example, a tree can bend in order to access light, right? It can develop roots that grow in a particular way in order for it to tap water. So, basically, one thing we can all agree upon is that motion, movement is very, very important for us. And now, that's where friction now comes in. Friction is a force that opposes or resists the motion between two objects. Friction is a force that opposes or resists the relative motion between two objects. Now, what is relative motion? Relative motion simply means that two objects are moving with respect to each other. Because no matter how you are moving, you are engaging in a form of relative motion, which means that you are moving with in comparison or with respect to another body. For example, if I'm lying down or if I'm walking or if I'm rolling, with with respect to the surface of my bed, I'm experiencing relative motion, right? If you're in a car, you could be sleeping in a car, but you are moving by virtue of the object you are in. So I may not be, I'm not moving in the car, but the car is moving. So I'm moving by virtue of what the object I am in. So that means relatively, I am also moving with respect to the ground, despite the fact that I myself am not moving. Do you understand what I'm explaining, class? Hello, everyone. I hope you understand what I'm saying. Are we there?
Yes, sir.
Yes, sir. Yes, sir.
All right, very good. So, like I'm saying, relative motion simply means that two objects are moving with respect to each other. So, all of our motions are relative to one particular object or one particular reference point. Usually, the ground is our reference point. So, friction now comes upon as a form of force. It's a contact force because it is not a force that can occur without there being contact. You have to be on walking on the floor, fighting. For friction to come in. So friction occurs when two surfaces are in contact or relation. Now, pass your ball across your room. Maybe you're doing some cleanup and then you have to move a very heavy ball from one side of the room to the opposite side of the room. Have you noticed something that as you are pushing it, you experience a resistance on the floor? Like you are pushing it, you discover that at a point in your
So I'm not hearing again. No.
Hello, class. Can we hear me?
Yes.
Yeah, yes, yes,
Okay.
I'm hearing.
Okay. Did we hear the explanation I was giving? Because I don't know what happened, then I got logged out. Did we hear the explanation I was giving about friction? I was asking a question.
No.
Oh, so that means there was a
No,
so that means there was a period you people were not hearing me. You could not hear me.
yes.
Oh wow, that must be a network issue. Because I was wondering, I was asking questions and I was even on the call, I was asking questions, I wasn't getting reply. I was wondering what happened. Then all of a sudden I got logged out. All right. Hello, can we hear me now?
Yes, sir.
Okay. So can you hear me? Can we hear me?
Yes.
Okay. So all right. So I was explaining something on friction and then network started misbehaving. So I was saying that for us to understand friction, we can't just jump into it. We need to do what? We need to go back to the origin. And I was talking about motion. I said motion is a change in the position of an object with respect to time. And then I now said that as objects move, did we get the part where I was talking about how motion is important for us as human beings, even all around the world? Was that part clear, or the network cut it out? Hello?
The network cut the stuff out.
Okay. So let me explain then. Let me just start again. Now I said for us to talk about friction, we need to talk about motion, okay? Because it is when motion occurs that friction rises up to counteract the effect of motion. I said motion is a change in the position of an object with respect to time. Like if I was in a particular position or at a particular place or at a particular location at a particular time, I can change, I can move to somewhere else. That means I have moved in layman terms, or in physics, I have undergone motion. So now, friction is now the force that opposes the motion between two surfaces in contact. Now, I said, let's look at this example of a man. Let's call him Nemika. So he's trying to push a wardrobe on the floor. And I was asking us the question. I said, have you tried to push a box across a room on the floor? You try to slide it in, or you try to push it and you experienced a form of difficulty in doing so? Has anybody experienced that? Have we?
Yes, sir.
All right. So that resistance that you felt as you were pushing it along the floor, as you're trying to, slide it along the floor, is actually called friction. Now, what is friction actually doing? It is resisting or opposing your motion. So as you are pushing the object, let's say in this direction, friction is acting in the opposite direction, trying to say, no, don't move, because friction opposes relative motion between two or more surfaces that are in contact. But we notice something which will carry us to the types of friction. The harder you try to push, it will become as though the object is becoming heavier, until a point whereby, as you are able to push to a particular degree or to a particular force, you discover that this object now easily begins to move. Have you experienced that? That immediately started trying to push it, just like a very good example is, those are neighbors those days, that when we were going to school, they can be like, please come and help me push this car or start this car. Initially, it will be difficult. We are all trying to push the car, trying to get it to start to move. Then after a while, there's a particular force everybody will exert, and you discover that, if I'm not talking about when the car starts, that's the car moving on its own. I'm talking about just able to push it so that you can be able to kickstart it. That at first you will be trying to push and push and push, but there's a particular force that everybody will exert on that car, and you discover that you're now easily pushing the car around before the car is even able to kickstart. Do you understand that? Have you experienced, especially maybe for the boys? Have you experienced something like that? Have we? Are we there?
Yes, sir.
Yes. Yes.
All right, good. So that means that initially, what was different? We're pushing this car, or you are pushing that wardrobe on the floor, and it was difficult. Up until a particular time, it now became easier. That's because you have now overcome the friction. At first, when you were pushing, friction was limiting, saying, no, this car is resting, it will not move. And it is in obedience to Newton's third law of motion that states that, or no, first of all, Newton's first law of motion that states that every object will continue in a state of uniform motion or rest unless acted upon by an external force. For example, your book will always remain in your bag unless you open up your bag and pick up that book to read it. Your phone will always be wherever it is unless you decide to act upon it. A ball will continue to roll in air. If I throw a ball upward, it should continue to go up and up and up unless another force, which is gravity, pulls it down. So that means that the moment where that car was static, what happens? The car is supposed to remain static. But then we decided that we want to start pushing. So that resistance, friction will come up to say, no, this car was resting initially, let it be. So it's trying to oppose your motion. That kind of friction, the first type of friction, which is the highest or the greatest power, that's the strongest type of friction, is called static friction. Now, what does static friction do? It prevents the object from starting to move because that body was at rest. let's say it was the example I used, the example of the car that you're pushing, maybe you're trying to help someone kickstart the car, or a box you're trying to slide. Maybe there are some things that are too heavy that you cannot carry them, but you can just manage to push them around the floor or slide them around the floor. So you notice initial resistance and initial difficulty. That friction that you experience at first is called static friction. I remember what I said. It is the strongest kind of friction, because what is the end goal of friction? I said friction is an opposition to motion. It is trying to resist that movement. The object was resting. You're trying to make the object to move, and friction is trying to resist it, saying, no, this can happen, this shouldn't happen. The object is supposed to continue resting. Now, the moment you're not able to push that object, you're not able to get it to start moving, you discover that it's now very, very easy for you to push it around, because you have now overcome the static friction. The second kind of friction is now called the kinetic or the sliding friction. Now, what does this one do? This one is that it's just like, okay, you have beat my brother, right? No problem. I'm going to come for you. So that means you have overcome static friction, which wanted to keep that object static, as the name implies, at rest without moving. So you are able to push and overcome, then the object is now moving. Now, kinetic friction will be working on that body that you've already started pushing to bring it back to rest. So that means the object is already moving. That's why the name kinetic is there. Kinetic means energy in motion. So the object is already moving. They've already started pushing the object, but there's another weaker kind of friction that is acting, seeing if perhaps it can bring that body back to rest. So that is kinetic or sliding friction. All right, kinetic or sliding friction. Then the third type of friction is called rolling friction. Now, rolling friction occurs when you are rolling objects. I have an image of that. Rolling friction occurs when you are rolling objects, because as long as there is contact, as long as you are moving across a surface, friction is bound to occur. So the question now is, what kind of friction is now the one that is going to occur? Now look at the first one, static. The object is at rest, not moving, and so static friction is just at rest and holding it permanently, let nobody move it. Then in sliding, you now came and said, okay, let me pull it around, let me pull it across. So sliding friction, static friction first will hold and hold and hold, then you finally overcame it. Sliding friction is like, okay, no problem. As you're sliding it, let's see if perhaps it would reduce its efforts. That's that kind of thing. Maybe when you're pushing and you now relax too much, you see that object will now stop. Are we following, please, so that I'm sure that everybody is getting the illustration that I'm making? Are we?
Yes, sir.
Yes,
All right.
sir.
I hope it is clear, the illustration I'm making. I hope you are all grabbing it.
Yes, sir.
All right. So that means as you have overcome static friction, you're now sliding the object across the surface of the floor, whether you're pulling it across or you're just pushing it across. So sliding friction, which is also kinetic friction, is trying to see if perhaps it can bring that body back to rest. Now, rolling friction is the weakest. That's why if you notice, for easy convenience, if you're traveling, you like to use that traveling bag that has rollers. This circular object here, like tire, is called a roller, because rolling friction is the weakest. Once you roll something over, it becomes very, very easy to move it around. Just like, for example, I've seen many people do it with tires, maybe car tires. Instead of carrying the tire, what would they do? They'll just roll it around. Same thing with even drum. Instead of just carrying it, they'll just roll it around. I hope you get what I mean. Even some people that transport like these GP tanks over short distance, instead of carrying it around because it's very heavy, what would they do? They would choose to roll the GP tank, because it is easier to roll objects due to the fact that rolling friction is actually the weakest type of friction. So let's come again. What are the types of friction? Number one is static friction. And as the name implies, for something to be static simply means it is not moving. So that means that is a friction at its initial stage, keeping that body at rest, not allowing that body to move. Then sliding friction is now you are pushing the object, you are sliding it across the surface of the floor. And as you are sliding it across, this object is already starting to move. So sliding friction is saying if perhaps it can bring that object back to its state of rest, where static friction was holding it firmly. Rolling friction occurs when you are using rollers, and it is the weakest type of friction. And that's why your traveling bags have rollers, your pen have rollers for easy rolling of that ball mouth of your pen. Do you understand? So rolling friction is the weakest of the three types of friction. Now these types of friction are called solid friction because there's another type of friction called fluid friction. In physics, when we talk about fluid, in biology, when you talk about fluid, you think about liquids, but in physics, we talk about fluids as anything that can flow. And basically, there are two, which are liquids and gases, because gases too can flow. That's why you have your tire. You can pump air from somewhere into your tire because air is a gas and it can flow. Even in terms of wind, you can say the wind is blowing. But in physics, we say that what it is flowing. That means air, which is a gas, is flowing from one region to the other. So these first three types are solid friction. They occur in solid objects. Fluid friction resists movement of objects through liquids and gases. For example, you can throw a stone through honey. It's not just going to fall as though it is in air. I hope you understand. You will see this kind of movement. Let me see if I can illustrate that. Whereby, let's say this is a jar of honey, and you throw a stone in there, you can see it, just sliding through the molecules of the honey before it finally comes down. It doesn't just fall in the water like that. I mean, the honey like that, which is a liquid, which is also a fluid. Same with the swimming pool. You can't just walk into a swimming pool and run across it because there will be resistance because friction opposes motion. There will be a resistance or an opposition to your motion by the molecules of the water in the pool. So that means friction does not only occur in solids, whereby, okay, I'm trying to move an object or roll a tire on the floor, friction is trying to hold me or break me. No, it also occurs in liquids. There is that resistance that you feel. A very good example also is when you're riding a bike, if you've been in a bike, and the bike is moving at high speed, you discover that the wind will be hitting you at very, very high speed also, which is the wind is showing you that as you are trying to speed through it, despite the fact that it is just air, you'll be feeling that resistance of the wind on your body. And the faster you go, and for example, even if it's raining, the faster you go, the harder you'll be feeling the water droplets hitting your body. Do you understand? Do you understand? Are we together? Are we in this class? Hello? Is anybody there? Can we hear me?
Yes, yes, I'm following. I'm following.
Okay. So far, did we grab all that I said?
Yes, sir.
Okay. So now, let's come again.
Yes, yes.
All right. Now, let's come again. Who can define what friction is? Yes, who can define what friction is?
It's the opposition. It is the opposition to relative motion between two bodies.
Exactly.
Yes.
Yes. So it is the opposition to motion between two bodies. Well, somebody else, because there are many ways you can define that. Is there anybody else? Somebody else, please.
Sir, friction is a force which opposes relative motion.
Good. It's a force which opposes relative motion. Very good. All right. Now, what are the types of friction?
Static,
Okay,
sliding, rolling.
good. Static, sliding. The sliding is not usually the name they usually call it at first. Kinetic, then, which is also sliding, like you said. Then rolling friction, correct. And there's a fourth one which is called fluid friction. Now, among all these types of friction, which is the weakest?
The rolling.
The rolling, right? And practically you can see it. Once you employ rollers in moving an object, it becomes easy for you to move that object around because rolling friction is very, very weak. All right. So we're going to now go on to the laws of friction. Wait, I didn't include it here. Okay, I didn't include it here, but we'll have to write it. Laws of friction. Before we go into the advantages of the law. All right, so let's go. Laws of friction. Now, the first law of friction is that friction opposes motion. The first law of friction is that friction opposes.
I can't hear you again, sir.
Now, the first law is that friction opposes motion. It's basically the definition of friction, and at the same time, it is one of the laws of friction, that friction always seeks to oppose relative motion between two surfaces in contact. Now, number two is that friction depends on the nature of surfaces in contact. Now, what does that mean to say that friction depends on the nature of surfaces in contact? It simply means that despite the fact that as long as there's motion, that friction will occur, it simply means that friction does not occur the same under different types of surfaces. All right, do you understand what I mean? Like, for example, if I am moving on a rough surface, the friction I will experience will be greater than somebody who is moving on a smoother surface. Do you understand?
Sorry, sir, can you come again? The second law.
Now, in the second law, I said friction depends on the nature of surfaces in contact. Okay, I think it's better if I'm typing it. Friction depends on the nature of surfaces in contact. Okay, let me get a new. All right. So, laws of friction. The first one is that friction opposes relative motion between objects in contact. Then, friction opposes relative motion of objects in contact. I'll still provide this note. It opposes relative motion of objects in contact, or relative motion of objects. Number two is that it depends on nature of surfaces in contact. Now, basically what that means is the nature soft or is the nature Is the nature soft or is the nature rough? Is the nature soft or is it what? Or is it rough? So it depends on the nature of surfaces in contact. Surfaces in contact. So I was explaining that. I said, for example, if you are moving on a wet floor and if you are moving on a dry floor, on which of them would it be easier for you to move easily? Which of them would you see resistance? So on which of them would you be able to see resistance? Wet floor or on a dry floor?
Dry floor.
Dry floor, right? Because on a wet floor, the surface is smooth. And so for friction to occur, it needs the surface to be rough. You understand? For friction to occur, it needs the surface to be rough because it helps with the cause of friction. Now let's go back to this diagram. Let's go back to this diagram. Now, no matter how smooth an object may look, it is actually rough when you look at it microscopically. Now, let's draw something here. Okay, let's use this one. Let's use this one. So let's see you have rough surfaces. Let's say this is the object you are pushing with a rough surface, and the ground, no matter how smooth the ground is, if you look at it microscopically, you will see that there are some rough edges. It's just that maybe they are tinier. If the ground is very smooth, then the rough edges will be tiny. Now, if these two surfaces are rough, let me draw it a little bit closer, downward and closer. If these two surfaces are rough, as you try to push this object across the rough floor, is going to be interlocking with the other rough edges of the floor. True or false? Hello,
Come again, sir.
I
Come
said,
again, sir.
okay, I'm coming again. I said that if two surfaces are rough, and I give an illustration, let's say this is the object you are pushing, it has rough, very rough surfaces, and then this is the floor, you're pushing it across a rough ground with rough surfaces. Now, as you're trying to push them over each other, they are going to interlock with each other, true or false, and you're going to have them grinding into each other, true or false?
Sir, it's true.
True, right? So that means the rougher the surfaces, the more the friction, because that's how you're going to get opposition. As you're trying to push it, that's why it's going to get difficult on a rougher floor, right? But on a smooth floor, let's say the surface is smooth, and you now have, even if it's a rough edge on a smooth surface, the friction will not be as much. And if both of them are now very smooth, then that means that what? Your friction is going to be minimal. So one of the laws of friction is that friction depends on the nature of the surface of the surfaces that is in contact. So that means, are they rough or are they smooth? Now, number 3 is it is independent of the area of surfaces in contact. It is independent. These are laws of solid friction, not just friction, because these laws don't apply to liquids. So it is independent of area of surface in contact. Area of surfaces in contact. Now, what this means is that friction does not need you to use a big area or a big portion. Even if it's just your palm, for example, you are rubbing one of your finger against one of your other finger, you can be trying it now. You are rubbing even just one of your fingers, tiny as it is, against one of your other finger. Friction is still going to occur. If you rub that long enough, you're going to experience wear and tear. First of all, you're going to be experiencing heat. If you're doing that, you're going to be experiencing heat. And if you continue that long enough, your hand, you're going to experience wear and tear. So whether it is a small surface that is in contact or a large surface that is in contact, friction doesn't care. Friction only knows to do what? Only knows to act as long as there's motion of the what? Of the object of surfaces in contact. Now there is also another law of friction that states that static friction, though I've seen some tests will put it, that static friction is greater than dynamic friction. Is greater than dynamic or kinetic friction or sliding friction. Is greater than kinetic friction. And I've explained the reason why. That friction primarily opposes motion. So that means it is strongest when there is no motion, right? It is strongest when there is no motion. And when motion has already occurred, friction has to do extra work to limit that motion or to bring that motion to an end or to a stop. So that's one of the laws of friction. Now, another law of friction is that friction is proportional with the normal reaction. Friction is proportional with the normal force or the normal reaction. Do you know what normal reaction is? Number 5. We can just have 5 laws. It covers everything we need. It is proportional to the normal reaction. It is proportional it is proportional to the normal reaction. So all these now will be very useful for us as we are going to solve very soon reaction. Now, do you know what normal reaction is? This is not just laws of friction, it's laws of solid friction. All right. So we have all that we need under the laws of solid friction. So now, do you know what normal reaction is?
No, sir.
Okay. Now, normal reaction is this, like, let's say this is a chair and you are about to sit on it. Now, there is a reaction that this chair has to give in order to be able to support your weight. So that means as you sit down on the chair has to react upward in order to carry your weight. Do you understand? Do you understand that, class? Hello, class. Hello.
Hello, can you come again?
Okay. Now, this is what I'm saying. I was explaining normal reaction. What I mean by it is directly proportional to the normal reaction. Now, normal reaction is the reaction from any support that is carrying your weight. For example, let's say this is the person. This is the person here trying to sit down on this chair. Now, as you are sitting, as your weight is coming down, the chair has to react upward in order to carry your weight. Else, you will fall down as you want to sit on that chair. So, normal reaction is an equal but opposite reaction to your weight. So, as you sit on a chair, sit on a bed, sit on a table, sit on a surface, that support that the chair gives from under, are you getting me? Let me do it again. You are sitting, let's take this. You are sitting on, let's say this is a chair. The chair has to act up in order to hold that your weight that is coming down on it. Do you understand?
Yes, sir.
All right. So that force is what we call normal reaction. So now, with this law now for the basis of friction. So number one law is that friction opposes the relative motion of objects. That means it opposes objects rubbing against each other. Then number two is that it depends on the nature of surfaces in contact. Are they rough? If they are rough, it means more friction. If they are smooth, it means no. That means no. We can say no friction anyways, because experimentally it's really difficult to eliminate friction. So it means reduced friction. Is that understood? Then I also said it is independent of the area of surfaces in contact. It doesn't matter whether it is a small piece of area or a large piece of area. As long as there is motion occurring, then what's going to happen? That friction is still going to occur. All right. So now, moving on from there, we are now going to start doing the calculations in this particular topic, friction. From the law of friction, the last one we just treated, what did he say? He said that friction is directly proportional to the normal reaction. And I'll explain what normal reaction is. Normal reaction is support that any surface you are sitting on gives in order to hold your weight. Now, if you remember from your mathematics, your variation sign, when you introduce your variation sign and you change it to equals to, what do you bring, class?
One over R.
No, like under your normal variation, when you
A
introduce
constant.
a constant, you bring a constant, and in this case, this constant is called the coefficient of static friction or coefficient of friction, which is called mu. So this is frictional force, frictional force, frictional force. This one is coefficient of friction. And of course, this is normal reaction. All right. So this is the formula for friction. F is equal to mu R, where mu is the coefficient of static friction. Now, you can just say coefficient of static friction is the ratio of frictional force to the normal reaction. But let me just explain what it means. Now, when we're talking about the coefficient of static friction, you're trying to say what is the strength of the friction, because friction occurs, yes, but to what degree? What determines the strength of the friction is its coefficient of static friction. It has a maximum value of 1. So that means if the coefficient of static friction is close to 1, then that means that you are very close to having a strong degree of friction. Now remember, we've not started solving, and the topic may begin to look kind of like only explanatory, but of course, we have to explain the concept first, so that when we now start to solve, everything would now be very clear. So your normal reaction is equal but opposite to your weight. Do we know that?
Sorry, sir. The arrow
Yeah.
is what?
Normal reaction.
Thank you, sir.
All right. So please, I hope we are getting all that I've been explaining.
Yes.
All right. So now, the normal reaction is your weight, because let's say, again, I'm sitting down. Let's say I'm sitting on a chair. My weight is coming down. If this is really going to keep me seated, what happens? It has to give a reaction that is equal to keep my weight. So my normal reaction is actually equal to your weight. Normal reaction is actually equal to your weight, but it is opposite. I can call it my minus W. Do you understand? Because your weight is acting downward on the chair, the reaction is acting upward from the chair to keep you seated, to hold and balance your weight. Is that understood?
Yes.
Yes.
All right. All right. So I'm glad we understood. So that means your normal reaction is equal to your weight. And what is the formula for your weight? Your weight is equal to mass times acceleration due to gravity. Okay. Is that understood? So let's take the first question. A block of wood A block of wood weighing 4 Newton is placed on a horizontal table. And then pulled. It just begins to move. When the spring balance, when the force pulling it is 3 Newton. All right. So I have this question that says a block of wood weighing 4 Newton is placed on a horizontal table and then pulled. It just begins to move when the force pulling it is 3 Newton. Calculate its coefficient of static friction. So let's now solve. So now the question says that the block of wood weighs 4 Newton. So let me push the question to this side so I can write on the other side. So a block of wood weighs 4 Newton. Now, let's draw a kind of like diagram. So this is a block of wood. Let's call this the block of wood. And the weight is 4 Newton, right? Weight is 4 Newton. And they said it is being pulled and it just begins to move when the pulling force is 3 Newton. So that means when the pulling force, it is being pulled by force. So when the pulling force is 3 Newton, it just begins to move. Then we are told to calculate the coefficient of static friction. Now, what is the formula for friction? Friction is equal to coefficient of static friction times normal reaction. Is everybody here following me, please?
Yes, sir.
Yes, sir.
Yes.
All right. Now, the force, friction, another law of friction is that friction increases to the degree of the force that that is causing the motion. That's why initially, no, okay, I didn't make mention of something when I was talking about static friction. Now, in static friction, I think that first, when the object is not moving, the static friction is holding it down, right? Keeping it static, not allowing it to move, right?
Yes,
So,
sir.
good. So, that means if static friction is keeping it down and not allowing it to move, and it does not have a value, then that means that object is never supposed to move. Are you getting me? So static friction has a maximum value, which is called limiting friction. So that means, for example, if an object is at rest, the static friction can be, that's why the static friction can be 10 Newton. And you came and you try and pull it, you try pushing 2 Newton, you try 3 Newton. But I have to make an illustration. So what I'm saying just not just um, look abstract. Okay, good. Still using this one. Now let's say, first of all, as this person came to push this box, the coefficient of static friction here, I get me. The static friction, sorry, the static friction is 10 Newton. Because of course you will not know, is when it is being measured. When you do the coefficient of static friction, you not get the static friction. So let's say 10 Newton. You came, you tried pushing with 2 Newton, the object did not move. 3 Newton, it did not move. 4 Newton, it did not move. 5 Newton, it did not move. 6, it did not move. 7, it didn't. 8, it didn't. 9, it didn't. Now 10, it did too, because 10 can hold 10. When you push, even if it's just 10.5 Newton, you now discover that this object will start to move. Are you getting me? So that means that friction can increase in value to counteract whatever force you are pushing. So as you're pushing with 6 Newton, it will not even use the whole 10 Newton, it will be 6 Newton with you, limiting you. As you're pushing with 7 Newton, it can be 7 Newton with you, limiting you. As you're pushing with 10 Newton, it can be 10 Newton with you, limiting you. Until you now go above that coefficient, that static friction. That's when you'll not be able to push this object. Do you understand what the illustration I'm making? Do you understand the illustration I'm making, everybody?
Yes, sir. But is it that the 10 is constant? Is that what you mean?
Now, I don't say the 10 is constant. I'm saying that the coefficient of static friction, okay, like you mean the value if it is 10, or are you talking of
Yes.
this particular scenario? No, it's not always constant. Like I just gave an example that if the coefficient of static friction is 10, for example, what that means is that except if you push above 10 Newton, that object will always be static. You hear me? If the static friction is 10 Newton, if you like push with 9.1, if you like push with 10, that object will not move because 10 Newton is what is a force that is being used to keep that object static. So if you really want the object to move, you have to keep trying and trying and trying until you overcome that static or limiting friction. Are you getting me?
Yes, sir.
All right. So let's move on. So we're here now. I was using that to explain. So that means you are pulling this object by this force here. All right. You're pulling by this force here. And then we're told the weight. Oh, no. And so we are now told that the weight is 4 Newton. Now remember, what did I say? I said that the normal reaction is actually equal to the weight. And in this case, is equal to 4 Newton. Is that understood?
Yes, sir.
All right. So what is remaining for me to get my normal reaction? Force, right? So remember, they did not give us frictional force. The body only said the block weighs 4 Newton and is being pulled by a force of 3 Newton. They didn't talk about frictional force. So then how do we get frictional force? So that's where I now make mention of this law, that the frictional force will always be equal to the force pulling, right? The frictional force will always be equal to the force that is what? That is pulling the object, because it has a value. That static friction has a value, let's say 3 Newton. As long as you keep pulling, if you pull with 2 Newton, it can reduce to 1 Newton just to hold you down. You pull with 2 Newton, you pull with 3 Newton. That means that the force will be equal to the frictional force will be equal to the what? To the pulling force to limit it. So that means this force of 3 Newton that is pulling it is actually equal to the frictional force. So the frictional force is also 3 Newton. Is that understood?
Yes, sir.
All right. So, having understood that, it's now easy for us to now get the coefficient of static friction. So, F, which is equal to mu times R, would now be 3 is equal to mu times 4. So divide both sides by 4 in order to get your mu. So your coefficient of static friction is 3 over 4. What does 3 over 4 give us?
0.75.
0.75. So that means your coefficient of static friction is 0.75. Now notice I did not put any units. The coefficient of static friction does not have any units. Is that understood? It doesn't have any units. So that's the answer. My point is refusing to come on. All right. So that's the answer for the coefficient of static friction. Is it understood?
Yes, sir.
All right. Let's take more. We
Please
also
come
have
again.
okay. I should come again on what exactly? Yes, I should come again on what exactly, please. I didn't hear you.
Yes, I'm seeing the place. I'm seeing it.
Okay. I will do the right thing. Like I said, I'll still provide the notes to you. Can I go on?
Yes.
All right. All right. So I would also like to deal with friction under an inclined plane. Let's also deal with friction under an inclined plane so that we can be able to solve jam questions on it. Friction under an inclined plane. Let's just do all needed of us once and for all. All right. So For friction under an inclined plane, this is what is obtainable. Please, I can hear my voice, so it's kind of okay. Thank you. So now, let's say this is an inclined plane, and an object is being pushed down the inclined plane. All right. So this is weight acting down. This weight is acting down, and this is the angle it is inclined, and this is the normal reaction. Let's say this is a normal reaction, and so this is the angle it is inclined at, theta, which is of course going to be the same with the angle here. Now, so we have an object and an inclined. Now this one is for friction of an object under an inclined plane. Okay, so in this case, the coefficient of the what? Are you getting me? The coefficient of the body, which is going to push this body, the force rather, which is going to push this body upward, is actually equals to mg sine theta. The force which is going to push his body upward is equal to mg sine theta. We can actually get it from a derivation. Okay, why the normal reaction in this case is going to be equal to mg cos theta. And remember, your coefficient of static friction from F, from our force, is equal to coefficient of static friction times R. F is mg sine theta, right? Is equal to mu. Okay, let me just not even do it yet. So to get my mu, it will be, to get my mu, it's going to be divide both sides by R. So my mu will now be F over R. And what is F? Mg sine theta over what is R? Mg cos theta. So by doing this, what do I have as my mu? Mu is equal to mg, will cancel mg, sine theta over cos theta. So my mu will be equal to tan theta.
Sir,
Yes.
sir, please can you help me explain that how you got that F equals to mg? Like when is it when are we supposed to put sine and cos?
Okay, good. Now I'm going to explain. Like as I said, it's gotten from a derivation. Now, do you understand what I mean by friction under an inclined plane? Yes. Yes.
So are you talking to us?
Yes, I said, do you understand what I mean by coefficient of static friction? I mean, friction under an inclined plane.
Yes.
Okay. Let me go to a new page and derive it there. Okay. Just I didn't want to bog us with the derivation, but anyways, let's do it so that it can be clear. Now, this is an inclined plane, right? Drawing. So this is an inclined plane, and in the inclined plane, you have a body that is sliding down, right? It is sliding down an inclined plane. So now, this is its weight will act downward, right? A weight of an object always acts downward. Now, on the plane, there's a normal reaction. Remember, I've told you normal reaction to support the weight of the object. Let's call that normal reaction R. So together, they make an angle theta with the plane. Is that part gotten first of all? So it's weight here acting downward. Are you getting me?
Yes, sir.
All right. So now from these points now, we can now try and get the component for the force, which is going to try and pull it up. Because remember what I said? I said this object is sliding down. So that means frictional force is going to be equal to the force resisting it, which is pulling it up in this opposite direction. Right?
Yes, sir.
All right. So now, let's now what? Try and get an equation for the F. Now, this F is also equal to this force, which is parallel. Because if you look at the direction of this force now that I'm going to draw, this one is equal and parallel to the direction of this one, F. Do you get me?
Mm-hmm.
You
Yes.
get me, right? So that means whatever value I get here, let me call it maybe F X, will be equal to the value of this one here, because they are equal and parallel. Is that clear?
Yes, sir.
All right. So now let's draw out this triangle that was formed. This triangle here that was formed. Let's draw it out. So if we draw it out, this is what we have. Angle theta, W, right? Then this is that F that I called Fx. And let me call here Fy. No, let me also do it here. Let me call here Fy. Now this Fy will be equal to my normal reaction. Are you getting me? Because look at the direction. Normal reaction. This is normal reaction. So Fy is also what? In the same plane. This same line is what I mean by same plane as my normal reaction. So both of them have to be equal. Is that gotten? So my Fy will give me my normal reaction. My Fx will give me the force that is what? That is pushing it down, while the frictional force is acting in the opposite direction. Is that understood?
Yes.
Is that understood? All right. What? All right. So, yes. So, in the next triangle now, you get how I got out this triangle, right? I did it by cutting out this particular one that you have here. This one here. Is that understood?
Yes.
All right. So we've established some facts that for the force Fx, it is acting in the same plane and direction as this one, the force pulling it down. And of course, that force is also equal but opposite to the friction, because I've already explained, right? That friction is equal to the force that is pulling the object downward. Now, let's go on. So we now have that if you can find Fx, what have we looked for? We have looked for frictional force. True or false?
True.
I hope you understand how, and we're not just saying it because others are saying it. Please, I hope you understand how this, because it's very, very important. That if we have looked for F of X, that means you have looked for friction too, because that component of F is equal and parallel. If you look at the direction, it is, where my pen? It is equal and parallel to the moving force, of which friction is also equal to it, but opposites, trying to resist the motion. Is that clear?
Mm-hmm.
Okay. So let's move on to get our FFX. Let's move on to get it. So now, what relation can I use? Trigonometry. Here is for theta, here is opposite, the side opposite of theta. Of course, here will be my right angle, because that's the plane. So that means my W is my hypotenuse, right? So if I'm to get F of X, it will be opposite. So what relates opposite and hypotenuse? It is sine theta. True or false?
True.
So sine theta is equal to opposite. Now, what is the opposite side? F of x over hypotenuse. Now, what is the hypotenuse side? W. So now what is f of x? It will now give that f of x if I cross multiply. F of x is equal to f of x will be equal to w times sine theta, w sine theta, of which w is equal to mg, which is mg sine theta. So that's how that one came about.
Okay.
Then to get my normal reaction, because I don't only need force, that same formula for friction applies, that friction is equal to mu times what r. So I've gotten my force, which of course that will also be my friction, because that friction is in opposite direction. I also need to get my normal reaction. And I've shown you that your normal reaction is in the same plane. If you look at it, it's in the same plane as what? F of y. So if I can get f of y, I have gotten my normal reaction. So let's get our f from there. Now, that means if here is opposites, here is hypotenuse, what's the last side? Adjacent, right? So f of y is adjacent. So what relates adjacent with hypotenuse is what? Cos, right? That's car. Is that correct?
Mm-hmm.
So cos theta is equal to adjacent over hypotenuse. Now, what is the adjacent side? Adjacent, as we've established, is actually f of y, right? So cos theta is equal to, so cos theta is equal to f of y over hypotenuse, which remains w. So f of y is equal to w cos theta, which means f of y, which is equal to my normal reaction, is weight is mg, then cos theta. That's how the second one was derived. But I didn't want to take us through the rigors of the derivation. But anyways, I believe it's also still straightforward. Do we understand it?
Yes.
Okay. So that's how those were gotten. So since f of y is in the same plane as r, our normal reaction is mg cos theta. Our force is mg sine theta. So with that, we have all we need to solve questions on that friction. Can I go on?
Yes, you can go on.
Okay. So wait, please, I would like us to have it though. I don't know if we can maybe take a screenshot of it, because it's very, very important. Are we taking a screenshot, or will we wait for a note? Even before the note, please let's add it. Because in the note I may not include
Yes.
the derivation. Do we have it? If you have it, just let me know so I can go on.
Yes.
Okay, let me also take a photo so I can include it in the slide. It's just not possible for me to take everything. Okay, I'm coming. Okay, I think this one will work. Okay, good. Yes, so I can have it as 1 now. Okay, so where's the other notes? So that means now what I wrote there now is now clear, right? Everything I wrote now is now clear. All right, so from here now, we can now get our normal reaction. Because our normal reaction, we meet the sort of formula is F over R, which is now F is mg sine theta, your R is mg cos theta, which is sine theta over cos theta, which is tan theta. So this is the equation for what? For coefficient of static friction on an inclined plane. You know, let's just go on and solve questions so that all this will become practical. The other ones are just theoretical aspect of friction. I want to see if I can finish it today because it's just a minute fraction. Sorry, let me. Okay, we have our Jam Remix past questions. Okay, good. So we have questions here under friction, viscosity, and surface tension. So I didn't talk about viscosity. Viscosity is also fluid friction. Okay. So now let's take the questions that follow. Question 1. Are we together?
Yes.
All right. So we read the first question. They're much. So we just take the ones we can. So the first one says the frictional force between two bodies A. Now let's look at the options. Okay. Is my screen very visible so that I don't have to go through a lot of reading all through? Is my screen very visible?
Yes, it's okay.
All right. So let's look through the options. Any question? I mean, sorry. Any answers? Let me know. What do you think the answer will be?
Sir, which number, sir?
1. Okay, let me just look through it. So like I said, based on what we've done, what do you think? Okay, let me just look through it together with us so we'll get it. It says frictional force occurs between two bodies A. Frictional force between two bodies, sorry, A exists only when there's relative motion or tendency for motion. True, right? Because I said friction opposes relative motion. So it exists only when there's relative motion or tendency. That's correct. B, it acts so as to oppose the motion. Is that correct? Yes. Friction opposes motion. Then C, it depends on the normal reaction between the two surfaces. Is that correct? Yes. D says is relatively independent of the area in contact. We mentioned that, right? We said it is independent of area of surfaces in contact. So that's also correct. Then E says has all of these characteristics. So what's the answer now? It should be obvious.
E.
E, right?
Sir.
Yes, so friction has all
Yes,
of these
sir.
what characteristics. Now, question 2 says, which of the following does not cause a reduction of the surface tension of water? Now, surface tension is another related activity, surface tension, though it's under another topic, but let me just quickly explain what surface tension is so that we'll be able to answer this question. Now, surface tension is the property of a liquid where it behaves like a stretched material. Are you getting me? Is the property of a liquid where it behaves as a stretched skin, and it is due to the cohesive forces between the molecules of the liquid. That means there are some times where you can experience water, so that water is a layer of skin. Do you understand me?
I
Hello,
didn't
class.
get that.
Okay. Now, I said there are some times whereby you can see a molecule of a liquid that looks as though it is a stretched skin. Let me give an example. There is an experiment we performed then, which is a floating needle on water, whereby as you put the needle gently on water using a spoon, that means you use a plastic spoon, for example, to put the needle on the water gently, you will discover that though the needle is denser than the water, that means denser in layman terms, though it is heavier than the water, the tight surface tension, of the water molecules will hold the needle up, and you see the needle will be floating in that water on your spoon. Do you understand what I'm talking about?
Yes, sir.
Another good example is when you see insects walking on water. Their leg push the water down, but the surface does not break, and it looks as though they are sliding through the water, though it's only for objects that are not really heavy like that, like the needle and then insects walking on water. Are you getting me? So those are two examples of surface tension, whereby it looks as though the surface of the water is acting as an elastic skin that is, in that case, keeping the insect up, and also in the case of the needle, still keeping the needle up. Do you understand?
Yes, sir.
All right. How about the rest, the other members, please? I hope we are getting me.
Yes, you are following.
Okay. Now, question 2 now says, which of the following does not cause a reduction of surface tension? Now, the things that reduces surface tension in water are your soap or detergent. For example, that's why if you notice something, I don't know if you've noticed, those same insects that will fly, that will perch on your water, if you are washing clothes, you see even flies that they will die inside that water, that same water. Have you noticed something like that? If they come on that water, they will sink and die.
Yes, yes.
Yes, yes.
Yes. Now it's because that detergent that you applied as you were washing, it reduces what? It reduces the surface tension. Same thing apply. Same thing will occur if you apply detergent, like I said, if you apply soap, if you apply alcohol, and if you apply grease. These are materials that reduce the surface tension in water. So, they are insects, they are already used to water supporting their weight like an elastic skin. But because this time you are washing, what happens? As they perch on the water doesn't support their weight, they sink in, and then they die, they drown. So this question now says, which of the following does not cause a reduction of the surface tension in water? Now the answer, of course, obviously, who can guess? What should the answer be?
Greece.
Is what? Don't be afraid to make an attempt. Of course, at least it's better to make an attempt here. Even if you don't get it, at least you learn. I love when you make an attempt. So which of them
Sir,
do you
this,
think
sir.
not? You said what? I didn't
Greece.
get you. Greece,
Sir,
okay.
Greece.
Okay.
Greece.
All right, good. All right, good. So I like your attempt. So you said Greece. Does anybody have any contrary answer?
Greece.
Do you have any? Okay, everybody agrees. Okay, but actually, the answer is actually camphor. I mean, camphor. You know camphor, right? That you put in your house. I think what is it for? To scare away? Is it insects? Something like that. Camphor does not affect the surface tension of water because primarily we don't even apply camphor to water. I said, for example, examples of materials that break the surface tension of water is number one, your soap. Number two, your detergent. Number three, alcohol. Even palm oil. If you add palm oil to water, you find out even palm oil, petrol, all those things. If you add it to water, you find out that those insects will not come there and sink anymore. And that's why if you're looking at Niger Delta area, due to oil spillage, insects, fishes die. Are you getting me? All right. So the one that does not reduce the surface tension of water is actually camphor. Most times camphor is the way used indoors. It's not applied to. If you apply camphor to water, it doesn't change anything in the surface tension. You get it?
Yes, sir.
All right. So moving on, question 3 says, a body of mass 6 kg rests on an inclined plane. Now, the normal reaction is, now it says the normal reaction is R and the limiting frictional force is F as shown in the diagram. Now it said if F is 30 Newton and G is 10 meter per second, then the angle of inclination is dash. It's also a straightforward question, but you would have to understand what they are doing here. Now, basically, they say that the normal reaction R is 10. Find the angle of inclination. Just have to. Okay, next time I will have splitted my screen. I've moved to the wrong page. Where's that question? Okay, yes, here it is. So I will have to move to another page so that each time I want to move. Now we know that F, because they told us to find the angle of inclination. Let's just do it here. I've gotten the power that we need. Come on. Do you already did. So F is equal to mg sine theta. True or false? Are we together?
Yes. Yes, sir.
Hello?
Yes, sir.
What's going on? Hello,
Yes,
I
sir.
be, okay.
Yes, sir.
Oh, thank God. Ooh, network has just been something else today. I was solving a question before I was cut off. I don't even know. Anyways, probably we'll just wrap up with that question. All right. So,
Sir, we are not hearing you.
hello, class. Can you hear me?
Yes, sir.
Yes.
Okay, good.
Yes.
So I said we're solving a question before I got cut off. So let's solve. Let's go on to solve. So this was the question we're solving. Question 2. No, question 3 says a body of mass 6 kg rests on an inclined plane. Normal reaction is R and the limiting frictional force is F as shown. Now the now told that is the limiting frictional force is F. You can see it's opposite the reaction. Opposite. So since this F is 30, if F is 30 Newton and G is 10 meter per second, then find the angle of inclination. Now, since they've told us that the frictional force is 30 Newton, they now told us to find the angle. So let's go back. I was about to solve before I got cut off by network. I've gotten the right parameters that I need, but it will be best for me to split my screen. Just give me a moment. Okay, good. Okay, this should be loading. Okay, good. Oh, I hope you are following me.
Yes, sir.
Okay, good. So this question 3 now says that if the force is 30 Newton and G is 10 meter per second, that we should do what? We should calculate the angle of inclination. Now they gave us that the force, frictional force. This is what I was solving before I was cut off. I said the frictional force is mg sine theta. We recall this formula, right?
Yes, sir.
Yes, sir.
Then they
Yes.
now told us that the force is 30 Newton and the mass of the object here is what? 6. So mass is 6. Acceleration due to gravity is given to us as 10. So then times sine theta. You can see it's not easy for me to get theta. So 30 will be equal to 60 sine theta. So in order to get sine theta, I'll divide both sides by 60. So sine theta will remain alone, of which 30 over 60 is half. So sine theta is equal to 0.5. Hope I'm not going too fast.
Yes, sir.
Okay. Now, Remember, this is a JAMB exam, so that means they are not giving you calculator. So what angle would the sine of it give me 0.5? It is sine 30 degrees. That's why they always give you question involving special angles. So that means number 2, the answer for that particular question is option B, which is 30 degrees. Is that understood for everybody here?
Yes, sir.
Okay, very good. Okay. So now let's now solve the next question, which is question 4. So we've ascertained that for question 3, the answer is B. Now for question 4, it involves knowledge of equilibrium. It says a mass of 2 kg, a mass of 2 kg on a surface U is equal to half is connected to second mass of 4 kg over a frictionless pulley as shown in the diagram. If the acceleration due to gravity is 9.8 meter per second squared, then the masses will dash. Will they accelerate at 4.9 meter per second squared? Will they remain stationary? Will they accelerate at 9.8 meter per second squared? Anyways, let's just solve. So it says a mass of 2 kg on a surface, right, is connected to a second mass of 4 kg over a frictionless pulley. That means friction does not occur in that pulley. That's what they mean by frictionless pulley. Now, the frictional force is equal to mu r because friction is acting on the first pulley. Okay, let me draw what I mean. This is the first object, 2 kg. Now, in this place, tension, there's a force, tension acting in the string. Are you getting me? So tension is actually acting in the string. That's considering the first body. You understand what I'm doing in class? Oh, you know what? Okay, I even forgot. We just started the JAM class. So that means we've not done equilibrium of forces. Okay, let me skip that one since we've not done that topic needed. But do we have an idea of equilibrium of forces? If we do, then I can solve it. But if we don't, so that it doesn't create confusion, then let me just move on.
So
Question. You said I should what?
let's leave it. Maybe when we treat the topic again, we'll go back to it.
All right, so let's just deal with the ones that are solely on the topics we've done. Now, question 5 says, which of the following about friction is not correct? So I would like us to attempt this since it's just a question about words, not calculation. Yes, so what do we think the answer is? Question 5. Yes, class.
B.
E.
What?
E.
Okay, let's look at this. It says which of these is not correct? The force of kinetic friction is less than that of static friction. Is that correct? Yes, right? Because I
Yes.
said static friction is greater than kinetic. Now the second one says the force of kinetic friction between two surfaces is independent of the areas in contact provided the normal reaction is unchanged. Is that correct?
Yes.
Yes, it's correct, right? Because friction is independent. Those other things are just extras. Now, C says the force of rolling friction between two surfaces is less than the force of sliding friction. Is that correct?
Yes.
Okay.
Yes.
So now D now says the angle of friction is the angle between the normal reaction and the force friction. Let's see. Says the angle between the normal reaction and the force friction. Do we have any relation like this among the formulas we treated? Any angle
No.
that gives us this? No, right? So the answer is actually D. Now let's go further and be sure. E says friction can be reduced by lubrication. The answer is yes, true. Where's that my presentation? Though I don't think we've gotten to that point, which is method of reducing friction. Lubrication is one of them. Lubrication is one of them. Because in reducing friction by lubrication, you are applying what's it called? A slippery substance. Yes, look at it here. Lubrication is one of them. Because I told you that when surfaces are rough, then friction is going to be increased there.
Okay.
So when you apply a lubricant, which is a slippery substance, it enables these surfaces to glide or slide over each other instead of over the rough surfaces. Do you understand?
Yes.
All right. So that means that one is actually correct. Lubrication is one of it. I don't think we'll be able to do this so that we'll be able to sleep. Or are we still active?
Come on, no, sir.
Okay, of course I understand. All right. So I'll provide the notes. So I'll be able to probably read through the rest. Probably read through this. In prospective class, then we'll finish up on this topic of friction. So far, is there any question or contribution? Want to contribute or want to ask a question?
Okay.
Anybody? Question, contribution? Okay, there's none. Okay. So that means we understood everything quite clearly and there are no issues. Is that the case? Uh, are we here? Are we still here?
Yes, sir, we are there.
Okay. So let me not infringe in on your night sleep. Okay. So it's already very late. I was expected us to have ended by 9:30. But this is already 9:51. So please do well to I'll provide these notes, of course. Now, if there is any question or probably anything that is you are studying and then maybe through the topics where we've treated, you were solving some question you could not solve it, please do well to reach out. Okay. Now for Vera, you're writing GC. Oh, where's Vera? She has gone. Okay, she has gone. All right, so in the absence of any other question, we can log out. So I want to thank you for your time, your attention. Do well to also study the notes that will be provided. Okay. All right. So good night.
Thank you.
Is there any other person
Nice.
writing?
Nice.
Sir?
Is there any other person writing GC?
No.
Okay,
No.
so we're all writing jam. Okay, no problem. So good night. Have a wonderful night rest. See you in our next class.
Okay, thank you.
I hope we learned a lot. Okay. Who is this? Emanuela? Is that Emanuela? Or Emmanuel? Hello, class has ended though. Emmanuel. Okay. I'm going off.